Today we are going to discuss about piping layout. Piping layout is one of the most primary design document in piping design. So as a piping design engineer, if you are proficient enough to develop piping layout, then you will be able to handle most of the piping design activities single-handedly. So without wasting your time, let's get started. Let's see what is piping layout. Piping layout is a drawing that depicts orthographical view, which is basically a plan view of a process unit to show the details of piping design. Generally, this plan view also consists of a sectional elevation view to show more details about certain areas where you cannot cover through the plan view. So piping layout is a drawing that actually details the piping design informations of one particular area of the layout. So we will try to understand in more details in the coming slides. It is generally referred as a general arrangement drawings or piping GAs. In most industries and most companies, it is referred as a general arrangement drawing, and piping GA is a short form of piping general arrangement drawings basically. So this looks like this. This is the plan view. In plan view, you will be able to see details like this. You will be able to see the piping and support details and structural details and the dimensions and boundary limits. All details will be available with respect to the piping. And this is an elevation view. In elevation view, you are going to show the more details which you cannot show in the plan view. Say for an example, the arrangement of the valves and supports and the elevations, which is clearly shown by taking a certain section and shown as an elevation view. Let's see some of the sample piping layouts which are actually used in industries. This is one type of a layout where you can see how the equipment is represented in plan view, and at the same time there are some activities carried out. These activities are shown over here in clouds. So generally in any piping layout, if you are going to modify some area, those areas are shown with the clouds. So that is to identify the new readers that this is the area where modification has been done. So this detail has been shown over here, the section AA. If you zoom this drawing, you will be able to find the section A and section A. So those details are shown over here. And moreover, piping layouts will also show a lot of other details such as the area of the plot. You can see the boundary limit. This is a south and this is a north, and then you can see the east coordinate over here, west coordinate and east coordinate. So you will be able to find the north-south coordinates and east and west coordinates of one particular area of the given layout that you are going to represent basically. And moreover, it will show you the north direction of the unit, so based on which you will develop the entire plot. Now let's go to the other layout. See the layout how it is. There are so many informations regarding the piping. You can also see the line number and the elevations and the support types, and there are cases even it is represented in isometric view also, because there are situations where due to the congestion of the piping you may not be able to represent both in plan or in elevation. So at those cases you will represent that in isometric view. So isometric view will exactly tell you what modification has been done. That is why we are delivering the isometrics drawings as also. So this is the purpose of a GA. GA is actually delivered in order to address all the details of one particular area so that the readers can easily understand what the modification has been done. Now let's go to the next layout. You can see this is the modified area and the sectional drawings are shown over here. You can see the north details over here and general notes over here, and in tabulation column, I mean in the nameplate, you will be able to find the details of this particular drawings, whether it is a piping plan or whether it's a plot plan, whether it's which unit and which area, all the details will be available. And here you can find references, which means references of any continuation drawings or the plot plans or any P&ID will be referred here for this particular area. And these are revisions actually, history of revisions, because generally the drawings goes to multiple revisions. So right from the revision 1 to revision 2, it will be shown over here. But for this video, let's understand what is the major requirements of this layout. Let's see what are the types of piping GAs available. Generally there are two types, key plan and normal piping GA. But what is key plan? Key plan is basically an overall plan which shows the partitioned layout. I will show you the exact key plan over here so that you will be able to understand what is key plan is. And piping GA is nothing but what we have seen now, which consists of either a plan view or a sectional view. There are cases where we used to put both plan view and sectional view in one drawing, and there are cases where the sectional drawings are separately detailed because of the information that is required actually. But the references of the sectional drawings will be given in the main plan view drawing. Plan view is considered as one of the major drawing, and sectional view is a supporting informations for the plan views basically. This is the key plan. See, the major difference between normal drawings and a key plan, I mean normal piping GA and the key plan is, key plan shows the entire plot and it will not show you the details of the piping. Key plan is to understand how many different partitions are being made. So here you can see the partitions of one partition over here and one partition over here and one partition over here, one partition over here. These are exactly divided into multiple partitions, 1, 2, 3, 4, like a box you can see. So this is one box and this is one box and one box. So each of these boxes are represented with respect to certain drawing number. So in order to refer the piping GA of this particular area, you have to go and refer this particular drawing number. Likewise, you need to refer the respective drawing numbers for each of this plan. So key plan is an overall area where it will show a partitioned layout with reference to the particular piping GA number, so that you will be able to understand for this particular GA you have to refer this drawing, and for this particular GA you have to refer this drawing. So this is the purpose of the key plan. Even for, if you just look at over here actually, so this is an entire plot, but where in the entire plot only this much of portion has been shown over here. The rest of the portions are being should be checked in the different key plan, which will be the continuation key plan of this particular key plan. So basically, key plan that shows the partitioned layout, that is what you have to remember in your mind actually. So this is what the drawing number that depicts the actually the reference drawing number where you have to go and find the piping GAs. So now let's go to the normal piping GA. Normal piping GA, we have seen multiple samples actually where it shows the north and the details of the entire modifications, I mean the layout in a particular area in plan, and the details are given more in elevation views and everything, right? So here you can also show the see the equipment and the existing nearby pipings and whatever structural arrangements over here, those also will be there. Piping GA is something that will show you more detail than any other drawings in the process industries, because all the other discipline drawings will only show you the respective information, but only in piping you can find the cable trays, you can find the structures, and you can find the lighting post, you can find junction box and everything. Okay, so as far as this video is concerned, let me just stick into my piping informations, otherwise we may not be able to complete. Now let's go to understand what is scaling is about. See, scaling, to understand scaling, you have to understand in a very conventional method. For example, scaling of piping GAs has two types. One is key plan and another one is piping GA. So in key plan, the scalings are generally made with 1:500 ratio and 1:750 ratio and 1:1000 ratio. So I'll tell you what is the number that actually represents actually, because you may not be able to understand now. So 1:500 is actually the 500 times it has been reduced, and 1:750 is 750 times it has been reduced, and 1:1000 is 1000 times it has been reduced. So more the number of ratio and more it is compressed basically. And piping GA generally are prepared with respect to 1:25 and 1:33. 33 and 1/3, because it generally comes 33.33 something and 1:100. So this is the ratio of piping GAs basically. Now let's go and understand what is scaling is all about. Then you will be able to understand the actual idea about scaling. Say for an example, let's consider Mumbai as a city. You know the square kilometer of the Mumbai is big. See, this is the map that I have downloaded from Google Map. So if you go and find Mumbai is a big city, right? Imagine that this Mumbai city, the entire map, you have to put it in a particular drawing. Will you be able to make a paper size which is equal to the actual Mumbai size? See, approximately the end-to-end dimension from here to here is roughly around 50 kilometer plus or minus 5 we can add actually, but approximately 50 kilometer. Do you think it is possible to have 50 kilometer paper where you can exactly show the actual size of the Mumbai? No, it is practically not possible. So what we have to do is that we have to print the entire size of the Mumbai with the printable size of paper. So that is very important. So we have multiple size, we have A3, we have A4, we have A2, A1, A0. So whichever type it has to be printed, accordingly you will convert the size, right? So it's not definitely possible to have the size which is equivalent to the actual size of the city. So that is why we used to scale down to the paper size. The entire size of the Mumbai will be scaled down to the available printable paper size. And when it comes to piping, you have different layouts, right? So you cannot have different sizes for different sheets basically. So in order to have the standardized size, these scalings has been standardized. So that is why you could see there are only few number of scalings. One is 1:25, 1:33, 1/3, and 1:100. So with respect to the sizes, and piping design engineers are good to choose their respective scaling standard. So that is what it is. Scaling also I will show you in one of the drawings, so you will be able to understand where scaling is mentioned. Now let's go and understand what are layout symbols. Unlike any other industries, piping layout has got their own symbols, like for elbows, T's, valves and reducers, and for all the different types of valves you have actually. To understand more about the symbols, you have to refer the piping drafting book, which I have already referred in my channel actually. If required, I will give you the link of that particular video in the description box. The description the particular link will give you the details of multiple piping design books, wherein I used to prefer the piping drafting book to understand the symbols, so that you will be able to understand how symbols are used. So in this video, we are not going to go into the depth of the symbols, because that is not the intent of this video. Now let's understand the design requirements. That is what more important. Now let's see what is the major input required. Generally, we have to start with the P&ID, where you will get all the piping design details. Then you have to know the line list, which shows the different temperatures and pressures and insulation required or not. And then we need to have a plot plan. Only in plot plan you will find the information such as an equipment locations, equipment details, exact space available. So that is primarily important. And fourth is layout specification. These are specifications generally given by the client basically. So the client will come out with certain requirements in order to ensure the safety, operation, accessibility, those things actually. So those needs to be followed. So that is why layout specification is very much important. There are companies that they indicate this as a piping specification as well, but generally it is basically how layouting needs to be done. That is the specification intent is about. Then we need to have the vendor drawings. Vendor drawings such as there are valve vendors and equipment vendors, and there are control valve actuator vendors. There are a lot of other vendors are there. So like a strainer drawings, you need to have what is the flange rating and what is the actual size. So spring supports, all the vendor details you need. Then you need to have the static and rotary drawings like pumps and pressure vessel drawings. Then you need to have the control valves and actuator details, because these details you get it from the CNA, like an instrumentation team. So these are not the standard valves, so the dimensions will vary, actuator size will vary, actuator dimension will vary. So these details you need to have in order to effectively plan your piping GA. And pipe support span. Pipe support span is also required, because you need to ensure that the lines are properly supported. So that is one of the reasons why the piping support is required. Now let's go to the design stages. Generally, piping layouts are developed in two stages. One is conceptual and another one is detailed design. Let's see what is conceptual and detailed design is. Conceptual is intended to develop the line diagram, so that you will be able to understand from where to where the line is going, how much of lines are there, how you can do the grouping, whether equipment needs to be relocated or not, because only if you do a line routing, you will be able to understand whether it is feasible enough or not. Accordingly, you will be able to move the equipments to the left or right to any other locations in order to increase the feasibility and the efficiency of the plan. Even line routing will really help you to rearrange the equipments to finalize the equipment layout. So that is why Even in equipment layout development, we have to do the preliminary line routing in order to understand and ensure the location of the equipments are right. So, in conceptual, generally we do the preliminary routing, then we will only do the lines which are above 2 inch. I mean, we can say 2 inch and above, because smaller lines are generally not considered in the conceptual stage. It could be done during the detail engineering stage. And we will determine the equipment location, because in conceptual stage, by doing the line routing, you will be able to understand whether the length of the line is more or shorter. So, accordingly you will ensure to increase the efficiency of the plant to move the equipment or not. Then you will be able to do the rack requirements, pipe rack requirements, then the entire space optimization. Only by putting a line routing, you will understand how to group the line, how not to group the line, where to put an additional rack and where not to put an additional rack, and all those things. Now, let's go to the detailed design. In detailed design, we will exactly go by dimension to dimension. So, every dimensions will be checked. So, that is what the detailed design is actually. We will exactly ensure the routing of each individual equipments with respect to the P&ID and the accessibility of the valves, and everything will be checked in detail. That is what the detailed design is. So, in detailed design, basically we do a complete detailed piping study, and we will finalize the nozzle orientations, and the platform requirements also will be addressed. And it will during detail engineering, you have to determine the exact rack size, I mean the pipe rack size, so that your the routing will be finalized, because unless you finalize the pipe rack sizes, you will not be ensuring the actual pipe routing actually. So, that is very much important, and you will receive all the vendor drawings, so that you will update all the final vendor informations, and then you will have to finalize all the information that is pertaining to the stress. Only then the stress will be calculated accordingly. If there is any impact in the piping layout, the stress engineer will update you. So far we have seen all the basic details of piping layout. Now let's get to understand what are the design guidelines of piping layout, how to prepare the piping layout. Let's start from the point 1. Point 1. In piping layout, generally the lines which are less than 6 inch and less lines are indicated in a single line in order to represent in the piping layout. At the same time, the lines which are 6 inch and above are indicated in the double line. I am sorry, it is 6 inch above actually. So, here we are covering the 6 inch. So, right from 6 inch and less, you will show in single line, and lines above 6 inch, which is actually starts from the 8 inch, indicated in the double line. It is only to ensure that the piping layout appears as without any congestion. So, if you are going to put all the lines in double lines, the entire layout will be congested, because the paper size is going to be very small. So, that is the purpose of this requirement. Now, let's go to the point 2. Point 2 is the line routing to meet the process requirement as per P&ID. This is one of the primary criteria in piping layout. You have to exactly meet the requirement, but there are cases where you may not be able to meet the P&ID requirement, and those cases you may have to discuss with the process engineer and look for an alternative. In case if you don't find any alternative, you may have to rearrange your piping. If required, you can rearrange the associated piping also in order to make a space of the entire area to meet the piping arrangement with respect to the P&ID. But meeting with the respect to the P&ID is far more important than any other requirements. Now, let's go to the point number 3. Point number 3. Piping should be as short as possible with minimum fittings for economical factor. Look at the picture over here where the pump pipings are shown. Suction piping and discharge piping. How beautifully it is made with less fittings. If you are going to put a lot of fittings, then it will cause a lot of economical factors also. See, longer lines and unnecessary fittings is in the line causes more pressure losses, and it will increase the cost of the entire project. Basically, if you are going to put more fittings and more elbows, it will reduce the live pressure in the line, and it will cause the pressure losses in the line, so which is basically a loss in energy. And also the number of fittings will increase the total cost of the project, right? If you are interested in learning piping design skills, then you can go to my website and go to the course tab, where you will be able to find 3 fantastic courses which is primarily created in order to improve the piping design skills for piping design engineers. So these 3 courses are considered to be one of the primary important design skills which are required for any piping design engineers. You can go to each individual courses to find more details of this course, and moreover you can also find my contact number in the details of this course. If you have any doubts about the course details, you can always contact me and I'll be able to provide more information. Now let's get back to the subject. So now let's go to the point 4. Point 4 is line should be located in neat and orderly manner. That is very much important. Let's compare with the plan A and plan B over here. So here you have a couple of equipments and there are pipings. So if you look at the pipings over here, so let's consider these 2 pipings which actually starts from the intermediate of the entire this rack actually. But at the same time, if you look at over here, these 2 lines are moved on the side of the line so that it can easily make a turn. And at the same time, if you look at the lines over here, here it is raised and here it is moved to the right so that it is neatly arranged. See, you need to prepare a layout in such a way it is neatly arranged. So line routing, this to be pre-planned and grouped wherever practicable to improve the aesthetic of the plan. That is very much important. In order to make the neat and orderly manner layout, you need to pre-plan your activity. If you can pre-plan your activity, most of the problems you can solve very easily. Okay. Now let's go to the point number 5. Point number 5 is about lines should be routed to ease the support arrangements. I could see there are maybe it's by experience it comes naturally. You can once you go through a couple of projects, you will be able to understand how the entire things works. See, there are candidates who doesn't understand about the requirements of the supports. So after finalizing the routing, they will look for a support. So actually we have to do vice versa. You need to see the possibility of support and accordingly you have to put the routing, or you can do parallel also actually. So if you are capable enough to route the line by analyzing the supports, then you can route a line along with the support. But the intent is that you need to route a line to ensure that there is a feasibility for the support provision. That is very much important. See, line routing to be pre-planned to ease simple supporting arrangement. You don't need to complicate the supporting arrangement. If you pre-plan your entire activity, you will be able to ensure that the right supporting systems are provided also. Now let's go to point 6. Point 6 is about pipes should not be routed at grade level where frequent movement is likely. Say for an example, you know that there are some particular location in the plant where there will be a frequent visit is required and a frequent maintenance is required, operation is required. But if you are going to lay or place any piping in that particular area, that will cause a lot of accidents like a trip hazard basically. So that is what I have written over here. Line routing at grade level causes trip hazard for regular operation activity and causes huge inconvenience for daily operation. Basically, it causes the inconvenience for daily operations and it will be considered as a trip hazard for regular operation activities. So that is what I have shown over here. Imagine you have 2 pumps and if you are going to lay a line in between these 2 space actually, so you are going to occupy the entire accessible area. So this is our area which is considered to be required for any operations or maintenance actually. So you, while finalizing the piping layout, you need to ensure these spaces are available as free. So that is your primary intent of finalizing your layout basically. It is not only for the pumps, it is also for any other equipments where you have to ensure that the space between these 2 equipments are not occupied with any lines which is at the grade level, so that it should not cause any trip hazard. Now let's go to the point 7. Point 7 is piping should not be routed above the static or rotary equipments. Generally, you should avoid routing the piping above the equipment because, so if you are going to route a line above the piping, you are going to cause a lot of inconvenience for the, doing the maintenance activity. Say for an example, here you have a crane over here. So during maintenance, using a crane, you have to lift the equipment. So in order to lift the equipment, you need to have the clear space. If in case you are going to provide a piping over here, definitely you will cause a lot of inconvenience for the lifting activity. So in order to avoid it, better pre-plan it while planning for a piping layout itself. You can avoid routing a line above the equipment. See, routing over the equipment causes access issue during maintenance activities and for the removal and installation of the equipments. So with this, let me just go to the next point. The point number 8 is all valves, control valves and instruments should be accessible. It's pretty much clear in any piping layout, you need to provide an accessibility for all the valves and instruments to be operated, because these are critical items. If you don't provide an access, then it will hinder the operation itself. So it's really important to understand the requirements and accordingly provide the enough accessibility to all these valves and instruments and control valves. See, accessible height should be maintained to ease the operations and maintenance activity, because if you provide somewhere in a place where you cannot access, then definitely it is not meeting any purpose. So it's really important to understand at what height you have to maintain and provide the accessibility accordingly. Now let's go to the point number 9. In point number 9, I wanted to tell you, see, pockets should be avoided at any cost in piping. I'll tell you what is the problem with the pockets. See, if you are going to have a pockets like this, it is going to collect some liquids, and moreover, the more number of elbows will cause a pressure loss. So what generally happens is that if the stagnancy of the liquid is high, during the high flow, it will cause a lot of hammering on the line. And for the loops which are on the above the piping, it will collect the gas, or it will collect air actually. So in that case, what happens, there will be a combination of both air and liquid that will also cause a slug effect or a water hammering effect. And generally, if you put more pockets, the suction for any particular equipment will not be met. So it's necessary to understand about the process requirements, where to put the pocket, where not to put the pocket. Generally in piping, pockets are not allowed. Pockets does not support process flow. So if you are going to have a lot of pockets in your line, definitely you are not going to meet the process requirements. Now let's go to point 10. Point 10 is about access for vehicle movement, and mobile crane and road access should not be occupied. So generally what happens in a piping layout development, due to various interferences and lots of coordinations, there are times that engineers tend to do mistakes. And the mistakes in such a way that they will go and occupy the access roads. So they will later come to know during the review that the entire piping has been made in the access road without knowing the importance of the access road. Say for an example, here this equipment, in order to lift this equipment, you need to park this crane over here. So if you don't have this particular space available for the crane, then how you will be able to remove this equipment? So what happens in the heat of the project, you may occupy this entire line for entire space for the piping. So if that kind of mistake, if you are going to make it, actually definitely you will have a huge impact in the later stage of project by modifying lot of pipings actually. So likewise, you can see here some vehicle has been parked over here in order to collect the catalyst waste from the reactor. So you need to ensure that these spaces are always kept free. If you are not going to ensure it, then definitely there will be a huge impact in the later stage of the project. So it's really important for all the piping design engineers in order to assess your accessibility and see whether any main road access or crane access has been occupied or not, in order to ensure the safety of the construction and everything, and also to allow to removal of the equipments and all. Okay, so all access roads for vehicles should be kept free for transportation and mobilization. This is a very important activity for a piping design engineer, because if you don't allow an access, definitely there is no purpose of designing. So designing to provide an accessibility for both operation maintenance is really important. So thank you so much for watching my video. I'll come back with another fantastic video. Until then, bye from Subhash Chandra. If you are interested in learning piping design skills, then you can go to my website and go to the course tab, where you will be able to find 3 fantastic courses which is primarily created in order to improve the piping design skills for piping design engineers. So these 3 courses are considered to be one of the primary important design skills which are required for any piping design engineers. You can go to each individual courses to find more details of this course, and moreover you can also find my contact number in the details of this course. If you have any doubts about the course details, you can always contact me and I'll be able to provide more information.